In this lesson, we're going to look at a data structure called a linked list, and we have three learning goals. The first one is that we should be able to explain the advantages and disadvantages of arrays, array lists, and now the new topic, linked lists. We should also be able to explain how a linked list is built using Java references, and finally, we need to be able to create and use a linked list to solve problems. It turns out that a linked list is very similar to an array or an array list, which begs the question, if I already have an array and an array list, why do I need a linked list? And to understand that, we need to look at the advantages and disadvantages of arrays and array lists, because it turns out that linked lists overcome some of the disadvantages. So starting with the advantages, if you think about arrays and array lists, they're very easy to create and use, typically just one line of code. And also advantageous is that when you want to access the elements directly, you can just use their index. For an array, you might say array and then use the brackets to access element 99. Or with an array list, it's the same thing, but we use the .get method. So arrays and array lists, they're easy to create, easy to access elements directly. But both arrays and array lists suffer from some disadvantages as well. And the main one is that arrays can't change size directly. And for example, if you had an array that had, say, 10 elements and you needed to store 11, you would have to make a new array that's larger and then copy all of the elements from the old array into the new array, which of course takes a lot of effort. Also, inserting and deleting creates some problems. For example, if you delete an element, then there's a gap, a hole that's created in the middle that you have to close by shifting elements to take its place. Or if you want to insert and there's no available spot, you have to shift all the elements down to create a spot to do the insertion. Now you say, well, wait a minute. I know that those are problems with arrays, but I have an array list, and an array list takes care of that for me. And in a sense, you would be right. It does take care of that for you. However, it really is doing all of that extra work of shifting or making a new larger array. It's just all hidden from you. See, it's called an array list for a reason. And so while there's methods to do all of that extra work on your behalf, it doesn't change the fact that that extra work has to happen. And in very large lists of data, that can be incredibly inefficient. And so typically, an array list is only a useful solution when you have a relatively small number of elements, because otherwise changing size, deleting, inserting all take a ton of extra work. In just a little bit, we'll learn how it is that a linked list can overcome some of the disadvantages that arrays and array lists have. But for right now, let's try to figure out what a linked list even is. And in order to do that, we need to remember that objects in Java are stored as references. So let's remember what that means. So for primitive data, the values are stored directly in the main memory. So for example, we have int x and its value 5 or whatever it might be is stored in the memory slot that goes with x. However, that is not true for objects like strings or anything else that we might have. For objects, the main memory doesn't contain the variables and methods for that object, but rather it contains a reference referring to where the object is actually stored. Now, if that idea is unfamiliar to you, you should go and watch my lesson on Java references, which will explain it in much more detail. Now, suppose that our object variable had as its own variable another object. In other words, we know objects store variables and methods. What if one of these variables was itself another object? Well, we know that objects are stored as references, and that would mean that our object actually references another object, and we would have a reference to a reference. And what if we kept going? Our first object has a reference to our second object, but what if that second object referred to another one, and that referred to another one, and so on and so forth? What we would get is this linear chain of connected objects, each one referencing the next, and this is what we call a linked list. So a linked list is really like a chain where one object references another, and so on and so forth. But of course, the follow-up question to that is how do we create one? And to see that, take a look at the class you see on the left, a class called ListNode. Notice that the class has two variables, an integer object, and then, interestingly, another ListNode object. So the class ListNode itself contains another list node. What does that mean? Well, let's take a look at an object of that class. List node n equals new list node. And what it will create is an object like you see on the right. Again, the class had two variables, so the object has two variables. The value starts off at 0, and then the next variable is a reference to another list node. Now let's suppose I said n, our list node, dot value equals 5. Notice the value on the right changes to 5. We know how to access the variables in an object. So let's further suppose then I wanted to change n.next. Now remember, n.next is a reference to another list node. And so in this case, I say n.next equals new list node. Well, new list node is going to build a brand new object, and it's going to put it in the chain. So the value got changed to 5, next got changed to a new list node. And the idea here is that in a linked list, each node added will reference the next one. This idea of adding nodes to our linked list really brings up the first advantage that a linked list might have over an array or an array list, and that is the fact that there's no size restriction. Really, we can add as many nodes to the chain as we want until our program runs out of available memory. Another advantage of linked lists is the fact that deleting is really easy. For example, suppose I wanted to delete the 7 node, that's the node in the middle of my list. All I really need to do is adjust the reference. And what I mean by that is that I can get rid of my next reference on the 5 and move it so that it skips right over top and refers to the 2. And in that way, I haven't really had to close any gaps or shift any elements. All I've had to do is change the reference so that it jumps over the one that I want to delete. Adding is also really easy with linked lists. Suppose I wanted to add that 6 node in between the 5 and the 2. Well, with an array or an array list, I would have to shift all of the elements to create a gap or a space where I could put that 6. But with linked lists, I don't have to do that. All I have to do is update the references. What I'd like to do is get rid of this reference, have the 5 refer to the 6, and then have the 6 refer to the 2. And this is what it looks like. And so without actually moving anything, we can just change the references, and the insertion is easy, and 6 is part of the chain exactly where we want it to be. Linked lists have a lot of advantages. There's no size restriction with them. We can add as many elements to the chain as we want. Adding and deleting is really easy. We can update the references, and we don't have to either create a gap to add or close a gap to delete. But not everything with a linked list is an advantage. And in fact, there's one very big disadvantage, and that is the fact that there's no direct access to elements. For example, with an array or an array list, I could just say n bracket 2 to access the third element, or if it was an array list, n.get2. But that's not a thing with a linked list. In fact, the only way to access an element directly in a linked list is to follow the chain from the beginning. And so that's why even though linked lists have some upsides, arrays and array lists are still a thing. It's like we have a whole menu of choices, and depending on what is important to us and what problem we're trying to solve, we can pick the solution that best meets our needs. Unfortunately, there is no perfect solution. All of the choices are going to have both advantages and disadvantages. Now that we have some idea of how a linked list works, it's time to start trying to implement one. So beginning with the list node class that I've already given you, I'd like you to create an add to that class. All the instructions are on the left side of your screen, and on the next slide you'll see a solution. So at this point, go ahead and pause the video, and then once you've tried this on your own, resume so you can check and see if you did it correctly. Here we see the complete list node class. Notice at the top we still have the variables for the value and next, and we have a constructor, and then we have setters and getters for each. So at this point, go ahead, pause the video again, and take a look at your answer. Fix any problems you have before going on. The list node class handles one node in our list, but we have to have a way to sort of organize them, to chain them together, to be able to add, to be able to remove, and so on and so forth. So what we need to do is add another class to our project called linked list, and we're going to begin with the code that's shown below. Notice that the linked list class has one variable called list, and list has a very important job. It's always going to be a reference to the first node in our list. So you can kind of see what that looks like over here on the right. So if I was to create a linked list object, I would say linked list L equals new linked list. And here we have our L, and a linked list is an object. So we have a reference pointing to our linked list object, and our linked list object has one variable called list, which right now points to null. But what list will be is it will be the starting point, and our very first node in our list will always be right here. And of course, there will be more that chain in after that. So go ahead, add this class to your project, start it out, and on the next slide, we'll add some additional stuff to it. Okay, on the previous slide, we created the beginnings of our linked list class, and we even made a linked list called L. But right now, the linked list can't do a whole lot. Specifically, we need to have the ability to add list nodes to it. So what we're going to do is we're going to create a new method in our class, public void add. And the idea is that when we call this method on our linked list, and you can see that right down here, if I say l.add5, it'll put the 5 node in. If I say l.add3, it'll put the 3 node in, and so on and so forth. So go ahead, add this method to your class, and then in the next few slides, we'll fill in the details of how that method is going to add nodes to the chain to make our linked list. Being able to add new nodes to our linked list is going to take a few steps. And the first step is that we have to be able to create a new node to be inserted. And so that's what you can see as my very first line. When the add method is called, the user is going to send whatever number they want added into the list. And then notice that what I do is I create a new list node, and it's called new node, and it creates a new list node with that value. So at the very bottom, we have the existing list, and then the line of code we just wrote creates this new node, which we will now insert into the list. Now that we have created this new node to be inserted into our list, the next step is to get to a point where we're ready to insert it. And so I've added a little bit of code here, and this code could be a little bit confusing. So let's just walk through it one step at a time and see what it does. The first line I have is I create a new list node reference, and I say list node current equals list. So remember that list is always referring to the first element in our linked list. Here it is right here. And so by making this new list node current and setting it equal to list, I'm basically creating an alias to the first node. Current is starting at the beginning. And then after that, I have a while loop. And the purpose of this while loop is to move current down the list one step at a time until we get to the end, which is where we want to insert our new node. So let's see what the loop says. It starts out by saying while current.getNext does not equal null. Well, let's check it. Current.getNext. That means this node right here. It is true that that does not equal null. So we're going to go into our loop, and the only line of code in the loop changes current. It says current equals current.getNext. So current is going to change to the next element, and we see that happen. And then we go back to the top of the loop. And it says while current.getNext does not equal null. Well, it does equal null, so the loop is done. But if we weren't at the end yet, current would keep moving to the next and the next and the next until it finally got to the end. Remember, with array lists, we can't access the elements directly. That's the disadvantage. So when we want to go to a particular spot in the list, in this case the end, we have to walk through the chain one at a time, and that's the purpose of our current variable. So now we're at the end. We've created our new node, and then the next step we'll actually insert it. To insert the new node, all I have is one line that I've added to our existing add method, which is right here. And it says current.setNext. So current, and I'm going to set the next. Right now, next is pointing to null, and we're going to change it. And it says set next to the new node. So basically, that's going to change this reference so it no longer points to null, but now points to the element we wanted to insert. And so what we can see now is we've added to the chain. So there were 3 steps, right? We made the new node, we walked down the list to get to the end point, and finally we inserted the new node at the end. At this point, our add method is basically done. However, there is one special case that we have to deal with, and that is when we try to add to an empty list. So notice at the bottom, I've got my list empty and I've got my new node over here to insert. And let's just kind of walk through the code and see what happens. So after we create the new node, it says list node current equals list, right? That creates an alias to the first element of the list, which of course there's no object there because the list is empty. And then the loop says while current dot get next. Now, when we go to current, is there a get next method here to call? Well, no, there's not, because that getNext method only exists if there's an object and we don't have one. And so what happens is this throws a null pointer exception right away, or a null reference exception, and it crashes our program. And so this code is good, like it's trying to work down the list to get to the end point and then insert, but in the case of an empty list, it throws an exception. So we're going to have to deal with this. And the way we're going to fix this is using an if statement. So remember that we've created our new node, and now what we'll do right at the beginning is we're going to do a check. We're going to say if list equals null. Remember, list always refers to the first element. So what we're saying here, if list equals null, we're saying if there's no elements, if the list is empty, then it will simply say list equals new node. List equals that first value, and now our list is not empty. The first the list reference now refers to the first element in our list. Now, if that's not the case, if the list isn't empty, that's what our else is for, and this would have the code that you saw in the previous slides. I just didn't put it in here because it was took up too much space, but that's the idea. So we check first to see if the list is empty. If it is, set the list to the new node. Otherwise, find the end using current and add it in. In addition to the add method, we'd probably like to have a toString method in our linked list so that when we would say system.out.println, our linked list, it would actually display all of the nodes. And so I'm just going to give you all the code for that. It basically works in a similar way to the add. Notice at the top, I start with a string result, which is just empty. At the end, I return that string. And so all the code in between, its job is to build that string to be returned. Just like I did with add, we start with a reference to the beginning of the list, and we loop as long as that's not null. And we collect the value along the way, result plus equals, and then we move current to the next node. So basically, current walks down the list. As it goes, it collects all of those elements and returns it at the end. If you haven't done so already, make sure that you add the add and the toString methods to your linked list class. In the lab, you'll have an opportunity to actually implement delete and maybe some other methods as well. But at this point, hopefully we've accomplished our learning goals. You should be able to explain the advantages and disadvantages of arrays, array lists, and linked lists, and all 3 of those have advantages and disadvantages. You should be able to explain how a linked list is built using Java references. And finally, you should be able to create a linked list and use it to solve problems. Keep in mind that actually being able to do that is going to take some time and some practice with the lab work.